In this video, I will be looking at the anim blueprint for the mover character that you can find in the game animation sample in content blueprints subword character mover ABP. And more precisely, I will be looking on this part, which is the main part of the anim blueprint, which drives the movement of the character. So this there is two setups here with motion matching and this one, and this is the experimental setup that combines the state machine, blend stack, chooser, and motion matching. And we will look how it works and then remake it with our simple character. And as usual, you can find the complete project file in the description. First of all, if you look at this, you can find it a little bit strange because it has a state machine, a blend stack, and two-way blend with alpha 1, which means that only this will be used. So here the trick is that the two-way blend node, it has this checkbox check it, always update children. So actually it will take the output of only blend stack, but it will run both of them. And this is why is it doing it like this? It's because it used the state machine just purely for the logic. It takes those transitions to travel from state to state, but if you go into one of those states, for example, we have here locomotion loop, you can see that there's nothing in there. And same for every other state, they're all empty. The only thing except the transition this setup does is that if you check this output node, it has this onState entry function, which will be called every time we enter in this state. And this function, they are all here on state entry with the name of the state. So all those functions do more or less the same thing. They will call this function, set blend stack anim from chooser. And as parameter, they will give this enum value. So those enum value, there is one for each possible state in the state machine. And that's the only, I would say, purpose of the state machine is to record the state. And then the rest is like the normal state machine. It will evaluate all those transitions and go from the state to state. So if we now go and look into this function here, so there's a lot of things going on, but we will be looking at, like, concentrating on the most important thing is the evaluate the chooser. So first of all, important thing about this function is that it is here in the advanced properties, it is marked as thread safe because we will be calling it from the other function. So we need this because it's called from the, not on the game thread, but on the animation thread. So here in this function, we receive the state machine and another parameter, state machine state. So idle, walking, etc., flying, the state of the other state machine. And the important thing is here, we will evaluate the chooser. Then we will store it output, etc. We will find the correct animation. And then at the end, we will set the members in a function, in a structure which is called blend stack inputs. And here we will store the animation to play and start time and some other parameters. And this structure will be used here in the blend stack. So in the blend stack, you have different parameters, which here was, for example, animation asset, which animation to play. Here it was directly, how to say, bound to the blend stack inputs anim variable. So the anim variable of this struct blend stack inputs, and the same here, animation time, where when the animation starts is bound to the time of this struct. And the blend stack itself, how it works, it's basically when this value of the animation changes, it will create a blend. And here you can also give the blend time and the blend profile as parameters, so it will blend those animation one after another. If the animation doesn't change, it will just pass it, play it, continue to play it, and loop it or not loop it, etc. It's like a player, actually, animation player. And when it's changed, it will also create the blend, and you can, as the name implies, you can have many active blends. Here it's limited to 4. And you can also blend from one animation to itself. If you set a flag here at the end of this function, we just call it force blend of next update. So if we need to blend from an animation to itself, for example, like it's explained here, if we playing something twice, so we can use that here and force it. So that's more or less how the blend stack works. And by the way, I recommend you to read all those comments because they're really very helpful and informative. And that's more or less the whole system. That's how it works. If you double click on the blend stack, there's another graph here, which will take the animation that we're playing it, apply some other procedural stuff on it, like for example changing the play rate, etc. That I will look later, but for the moment what I will do is to reproduce this system with all simple character. So I'll go into our other project. So as you remember, we have this very simple anim blueprint with the state machine, wait, which plays wait, idle and move, which play this blend space, and then 2 transitions, also pretty simple, when it's moving and when it's not moving. So what we will do, we will duplicate the state machine, go in there and simply delete this. And now we will on state entry bind a function. Here I already created them, otherwise you do create binding, and I will bind the function on entry state idle, which is, as you can see, simply the same thing that before and in the other. On state entry idle, we'll call a set blend stack anim from chooser with idle. And same in the move, we will delete this, and then here bind on state entry walk, which I already created before. Same thing, but we say that the state is walk. This function will evaluate the chooser and set up the struct for the blend stack. So this function also, I already did it. It takes the state, set it in a variable here, state, and then it takes this chooser, evaluate it, take the output. I have really simplified everything, and then it will store this in this struct blend stack input. So anim and start time. So we can see that here I have this. I have created the enumeration state, which has 2 entries, idle and walk. That's our variable state here. And then I have this structure blend stack input, which is here. which is also very simple compared to the other. It has the anim and the start time, animation asset and float. Okay, so I have those two variables, state, blend stack input. I also save the chooser player settings, which are of the predefined type chooser player settings that we will see how we can use after. So that's it here. To repeat it again, we take our locomotion state machine, we delete the actual animations, and we add the onState entry function that will just set the state variable and then evaluate the chooser and set the selected animation, etc. here. Then we will create the blend stack node. Blend stack. And here we have the various parameters. So animation asset, we will say we will bind it to blend stack input, the struct we assigned just before anim. And we have start time. We'll bind it to blend stack input start time. So the other example also binds other variables that it's taking from the chooser. So now we will create this two-way blend node alpha 1. That means we only taking the output from here, and in the parameters we will check always update children and put it here. Now what we didn't check yet, so we have this function, we use the chooser I created before. So to create the chooser, you go here, animation, and chooser table, you choose animation chooser. Anim class, you choose our ABP my mover pound, our anim blueprint. Create it. And then here you see that it uses the ABP my mover pound and this chooser player settings by default. Here what we have to do is to add a column, and as we've seen, we save the state enum. So here we check the enum and then bind state. Okay, and then we can add row set. If the state equals idle, we'll play the tutorial idle. If the state is equals walk, we will play tutorial walk forward. And then if we want to assign the variables to this output struct, chooser player settings, we add a column here, which is output struct. We have to bind it to this. And then here we can put something, for example, start time 1. I don't know, all those values. We don't really use it, it's just for show how it works. Okay, so that's what I already did here, and I use this my mover pound chooser table in the anim blueprint here in the evaluate chooser node. So now if I compile it and I go into my map and I hit play, you can see that it works. That's it for this video. In the next video, I will be looking into the motion matching part of this experimental setup. As before, you can find the link to the project files in the description. Thank you very much for watching and see you.